All right, so we're going to look at creating relay logic, creating relay logic diagrams. If you've already had motor controls, how many people in here have had motor controls? How many people have had air conditioning? Okay. Either way, there are a couple of classes in air conditioning where y'all look at relay logic, and then motor controls looks at relay logic. And this being the second time you've seen relay logic, it's going to make a lot more sense than it did the first time. So if this is the first time you've seen it, then when you take motor controls, it'll make a lot more sense because that will be the second time you've seen it. We will work with it quite a bit in here, though. All of the programming for the PLC is done in ladder logic. Okay? So, it will let you make a mistake, but it won't run if you make a mistake. So you have to go back and figure out what you did wrong in your program. Okay? All right. This is actually starting to get into the fun part of this class. We're going to look at using symbols to represent different types of input and output devices. We're going to create relay logic diagrams using normally open and normally closed inputs. Okay. We're going to look at relay coils. We went down and actually looked at the coils themselves, but we're going to look at it in the diagram. We're going to create relay logic using standard rules, and we're going to look at placing comments on the sides, and by that I mean being able to track things and where they are in the diagram. So the first of it talks about symbols, and if we look, part of this may actually still be in Chapter 4. Okay, we went down and looked at the components. Alrighty. But if you go back in Chapter 4, if you look on page 68 and 69. I forgot to turn on my pen. I think I want blue. Okay, so we've got push button symbols on 68 and 69. And these are for relay logic. These are not for PLC logic. Are you okay? PLC logic changes things, so we'll get to PLC logic in the next chapter. But this is, if you were doing motor controls or relay logic, this is what you would use. Everybody okay? All right. Notice on the bottom of 69, the very last two push buttons, the double pole, the two double poles. See those? Actually, the last four. Notice that they are connected with dashed lines. Do y'all see that? And that means that they are connected. That means they operate simultaneously. Everybody okay? All right. Symbols for limit switches, mushroom switches or E-stops, float switches, flow switches, temperature switches are all on page 71. So basically, switches are on page 71. Actually, 70 and 71. I could go through and explain to you about these, but it would take a lot more time. Really, the only way you're going to know these symbols is if you use them and just start drawing them. So, and like I said, most of this changes for PLCs. So I want you to know what they are. I want you to look at them, but I don't necessarily want you to try to memorize all these push buttons and switches, okay? There are a few that may be important, but right now, let's just use the book to find the symbols, okay? Just a couple and where they're used. A float switch. What's the most common place you think you find a float switch? In the back of the toilet. Everybody okay with that? Everybody know how it works? Okay. How about a foot switch? Automobile. There you go, the car. Which one's a foot switch? The gas pedal and the brake pedal, right? Okay. So those are common foot switches. So we do use push buttons or we do use different switches all the time. We just don't really think about it. Sensors are another thing that we can connect up to the PLC or to relay logic, either one. Sensors can be used in different ways. The sensors actually have different symbols for what they do. So we might have I'm trying to think of some sensors right now, like a proximity switch or a proximity sensor. And what happens is it knows when something gets close to it. We might have an inductive sensor. It knows when metal crosses past. A photo sensor. It senses light. Okay, so those are different kinds of sensors that we have. Uh-huh.
What are those, how do they operate? By the weight or like go into a store somewhere, automatic doors?
I'm not sure. I think they operate by weight on the pad, but I'm not positive. Some of them may do by motion, but the ones that do by motion actually have a sensor up here. But some of them actually may do by weight. Yeah, it'd be kind of like a scale, but it would have a sensor underneath it that would trigger it. Very similar to a no, that would be the motion sensor, would be something like that. And it would be set up where you could break a beam. But it would be more like a pressure sensor, yeah. But they may actually have a beam. Your garage door. How many of y'all have an electronic garage door? What happens if something gets in between? Do y'all have, if you have a new one, they come with these sensors, and you have to set them up, and you have to align them right. Okay? If something gets in between them, what happens? Door goes back up, right? Yeah, but it's crushed a foot if it's underneath there. Okay, so the new ones, though, actually have the light sensor, so they know if something breaks the beam. The old ones had a pressure sensor, so if the pressure got too much and it had to push on it too much, it would allow it to go up. But if your hand was underneath those old ones, it still broke your finger. So, but the new ones actually use a light beam. The other night when it was so blasted cold, the night of the Auburn game, as a matter of fact. I left here, went home, hit mine. It came down. Well, it was so cold, I didn't want to stay out there and watch it. I just went in the house. And a little while later, a couple hours later, my water was frozen because something got in between that beam and the garage door never went all the way down. So, sensors are nice, but, you know, sometimes they don't do exactly what we want them to do. So, but anyway. All right, so we got symbols for push buttons and switches. There are relays. If you look on the bottom of page 79, they actually have the contactors, or basically I believe that would be a motor starter, okay, with the contacts on it. And then, of course, it's showing it attached to the motor. And if you look, it actually shows you a relay logic on page 79 that would be like what you would see in motor controls. Everybody okay? Somebody's alarm going off. We would actually wire these, like on page 83, they actually show the motor starter and how it's wired. And Leoris asked a question while we were down the hall about if this thing tripped, would you have to actually go in and reset it? And yeah, you got to go down the hall and reset this thing. But what we don't have to do is use the contacts off of these coils anymore. The PLC will take over that part, and you no longer have to do that. And then we have motors, or motor drives, and actually they don't really give you a good symbol, but all it is a circle. It's actually at the bottom of 83, they show you the motor. But really when we're drawing a motor, and mine's kind of squiggly, I'm sorry. But that's basically a motor. We just do a circle with an M in it. So that's your motor. And I did all those symbols without needing this. All right. Rule 1 says that all input devices are to be placed in the left corner of the rung. Okay, so I need to back up for just a second and explain ladder logic. So I'm going to go ahead and back up to this page, and we'll do ladder logic on here. I got a blank page. Ladder logic is actually an electrical diagram, okay? But it looks like a ladder. We have line 1, which is a volt. It ran into my other line. Okay. Line 1, okay? And line 1 is a voltage coming in, okay? We also have line 2. So I get voltage between line 1 and line 2. How much voltage do I get if they never connect? None. Everybody okay? Everybody knows also, if anybody in here is electrical, you have to have a potential difference between 2 points, right? If they're both at 120, I still get nothing, even if I connect them. Everybody okay with that? So, but because these are at different potentials, different voltages, when I connect something in here, and I'm going to short this out. So when I connect those two lines together, I have now shorted them out and I have voltage flying past there, okay? I wouldn't do that, okay? What I would do come on. Yeah, go back to my pointer, I'm sorry. What I would do is put a switch in here, or a push button. I'm just going to put a push button. And I'm going to put some control. So let's just say this is a light. I don't want to put, I'm going to say it's a red light. Okay, so it's red. So now if I push that button, that red light comes on. Y'all understand why? If you don't, please tell me, because I need to explain it. So if I push this push button down right here, I push it down, it makes contact between those two terminals. Now I've got a straight line all the way through and allows voltage to go to my red light and turn on my red light. Okay, that's a very simple circuit. The reason this is called a ladder diagram is because this is not the easiest thing to draw on, I'm sorry. Okay, so now I got a green light. So the way this works with the two voltage lines, they're usually darker. I just can't really draw them thicker, okay? But you would draw the outside lines thicker, and then each thing that you do has a rung. So then now it looks like a ladder. If you were to start at the bottom, you could step your way up on the ladder. So it looks like a ladder. Everybody okay? That's where it gets its name from. So this is called ladder logic. I have things that I do in a logical order to get it to work, and it looks like a ladder. Everybody okay? Okay, and what Rule 1 is telling me is that all of my inputs have to go on this side. Y'all okay? I should say it. I don't know. It's under Rule 1. I just got my new book, so my page numbers are all messed up.
And for instance, in 240 volts on a contactor, you've actually got a contact for both legs. Would you not show a set of contacts on leg 2 as well?
I don't think I followed that question.
Like when we were in AC, when we had to do our diagrams for it, on a contactor, you've actually got a contactor. It's actually a set of points for both legs. So you've got
Yes, and you would have to connect them.
So even in that situation, you would have to put a set of contacts on the right-hand side because there's a set of contacts on leg 2 as well, though. So it wouldn't.
But yes and no. Those are actually not contacts. Those are what we call thermal overloads. They look like contacts, but they're really thermal overloads, and they are part of the motor. Are they not? Aren't they part of the...
It's actually not a part of the contact.
Huh.
Because you got a 24-volt coil. The coil backs up in the points. When it pulls in, the points make up the contactor. There's actually one on leg 1, one on leg 2.
Then you would have to hook it up to leg 2, but it's not really an input device.
Okay. That's what I was saying.
Aren't they normally closed?
No, normally open.
Normally open. Okay, but they're waiting on...
To energize the coil. That's why I was just
I'm gonna have to go research that with Jeff or Brian.
I was just wondering because
But if they're attached to line 2, they have to be there. I thought they were magnetic overloads. I mean, I thought I really thought they were waiting on something to kick out, not kick on. So I'm gonna have to go look that up.
I was just wondering.
That's a good question, but I still have to. I'll have to go look it up. But input devices, switches, push buttons, all that has to go on line 1. Those are still not switches. They're contactors, but they're not switches. So all your input devices go on the front side. Yeah, I'm backwards from y'all, so this side. Yeah, okay? All right. Rule 2. One and only one output is to be placed on the right side of the rung. You cannot have 2 loads in the same rung. Okay? So going back to over here, I could not put another light right here. Okay? That's a big fat no-no. Can't be in series. And they always have to stay to this side. Can't have 2 loads in series. 2 output devices, whichever way you want to word it. So motors, pilot lights, relay coils, motor starters, all have to have total voltage, so we cannot put 2 of them in there together in series. Yeah, okay? Rule 3, input devices can be connected in either series parallel or series parallel. And you're going to think that's a stupid way to write that. But if you look at, let's see, do they have an example for Rule 3? Well, that's showing a I think I combined 2 rules. Actually, yeah, I'm actually looking for, but that looks like it's Rule 6, so we'll just go on. So, series parallel or series parallel. I don't know what other way you could combine them. I guess you could put one leg on one rung and one on another, and that would mess it up. Only parallel devices may be placed on a rung. Parallel output devices, I should have said the output. So if you look at the top of page 93, I believe, I have switch 1 and switch 2 and a push button that's controlling the motor and the light. But notice that the motor and the light are not really on the same rung. They're in parallel. Y'all with me? Yes or no? It's going to be a long night if y'all don't answer me. Thank you. All right, Rule 5. While input devices can be represented multiple times in a relay logic, every output can be represented once on the diagram. So I can repeat my push buttons. I can reconnect to my push buttons, but I cannot do that to my outputs. And I'm looking for Rule 5. These same rules do apply for PLC logic also.
That means if you have 2 motors, so you won't call it M and M, you just have to have M1 and 2.
That's correct. It would have to be 2 separate motors. So, do what?
Just not the same name.
Can't be the same name, can't be the same motor. So, you would not take let's just say motor 1, and wire one set of switches up to it and then wire another set of switches up to it. You can't, that, you know.
Here it's two different runs, but the way it shows that you cannot have two red lights,
It can't have 2 red lights and you can't have 2 motors.
even though they're controlled by different switches.
That's correct. You can't. That's what I'm saying. You couldn't run 2 sets of switches to that motor. Now, if you wanted to do it this way, you could put them in parallel. You see,
Page 94 shows it again where it's hooked up right.
yeah. So they're showing them in parallel now. You can hook up switches in parallel and run them, but you can't put the same motor in there twice and the same red light in there twice. Matter of fact, I believe there's a test question that says, how many times can you hook up an output device on relay logic? You can hook up as many as you want to, but each one can only be hooked up one time. So the answer to that's one time. No, I will not. When I say this is a good test question, you better listen the first time. This rule takes care of it, though. Just remember the rule and you'll be okay. All right, let's see. Rule 6. All the input and output devices must be placed horizontally. Think about a ladder. The rungs are always horizontal, right? Do you ever see any rungs going this way? Your foot wouldn't quite stay on it, would it? Well, neither will the push buttons. So, if you look on page, I saw one of these a minute ago. If you look on page 94 at the bottom, they have a switch 3 that they have put in there vertically, and that's not allowed. Yep. So if you look, they changed it in 513 in figure 513, and they changed it over to be a horizontal. It's still connected exactly like it's connected. It's still connected straight between the two, and it would work the same way, but they're just not allowed to do them that way. Okay, everybody all right? All right. Rule 7 says that current flows from left to right. So if current flows from left to right, looking at diagram 514, if I showed you this diagram and I said if switch 1 and switch 2 are closed, would the electricity go through switch 5? If only switch 1 and switch 2 are closed and switch 5 is closed. Would it turn on the red light? No, it won't, because it can't back up. Everybody with me? So it will only go in one direction. It's a one-way street, guys. So it can turn, but it cannot turn around and go back. Okay? Think about it like water. It can't turn around and go back upstream. Okay? It can go around rocks, and it can do all kinds of things like that. But it never can turn around and back up to go forward, right? All right. Well, yeah, it says that, but it also can't back up. So if you look at 514, see it shows it going through 1 and 2? And see the orange line that shows you the incorrect one? It's showing you that it will not come down, go through push button 2, and then back through S5. So that's what it's trying to show you, that it can't back up. It's got to keep going forward. Do what now? That's correct, yes. If S1, S2, and S5 are closed, nothing's going to happen. If switch 1, switch 2, and push button 1 is closed, then the motor comes on. If I'm coming through 3, let's see, switch 3, if I close switch 3, and I close push button 1, then the motor comes on. And if I close switch 4, then the red light comes on, and if I close both of them, of course, they both come on. Or I could do switch 5 since I got switch 3 closed. Yeah, okay? Okay. It can only control the light, but it can only control the light if switch 3 is closed. Because switch 3 is the only thing between it and line 1. Okay? All right. Rule 8. Diagrams have to be numbered and commented correctly. Rung numbers are to be placed above the symbol. I'm sorry, rung numbers are to be placed on the left side of each rung. Comments are to be placed above the symbol. And rung comments are to be placed on the right side of each rung. If you've never had motor controls, this is a little look at 96. So notice that this thing has 3 rungs. Everybody okay with that? See where they're numbered? 1, 2, and 3. The instructions that they're talking about above the symbols is like what it is. So above the push button, notice I have PB1. Y'all see that? So that's telling me that that's push button 1. And that's what it's referring to when it's talking about the instruction comments. Now the rung comments, turning on motor 1, you're not going to see these guys. Very rarely do you have somebody write these over the side. Now what you may see is if you have relays, they'll put the relay numbers and where they go in the what rung they're in, okay? Like in 516. And I have seen these in different ways. So if you look at rung 1, notice that there's an M1, which is a motor starter, okay? And notice that there is a contact called M1. M1 is a coil. Maybe a motor starter or a magnetic starter coil, but it's still a coil. So it has contacts off of that coil. So if you energize M1, then all of the contacts go to their not normal state. Okay? And I said it that way so that you know that all the ones that are normally open, close, and all the ones that are normally closed, open. Everybody okay? Yes or no? Okay. All right. So if we look at rung 1, we have an M1 coil. the 1, 2, and 3 over to the side tells me that I have a normally open in rung 1, I have a normally closed in rung 2, and a normally open in rung 3 without me ever looking down the diagram. The reason I know that is 1 and 3 have no underline, okay? Rung 2 has an underline. I have seen these different ways for different diagrams. In motor controls, a lot of times, if you're doing them by hand, you will see an overline as opposed to an underline. You can do this if you're drawing it by hand. It is very hard to overline something in a computer. The computer just doesn't want to put an overline on it. So that's why a lot of times you'll have one that is underlined. That's easy to do. And then the other one means the same thing, normally closed. You'll see a little tilde sign behind your 2. And all of those mean the same thing. It's a normally closed contact. Everybody okay? And y'all know what I mean by normally closed contact, right? But the other comments like turn on M1 and turn on green light and turn on red pilot light, you're not going to see those. In PLCs, unlike motor controls, I can have contacts off of anything. I don't have to have a relay. So if I want a red light to turn on something, I can have a coil I can have a contactor off of a red light. The PLC's controlling it, so all it says is if this red light comes on, then close this. So we can have contactors off of any output we want to have. They don't have to be pre-made with coils. That really confuses the heck out of y'all that's taking motor controls, doesn't it? Or not confuses you, but that just kind of one of those real odd things. All right. Everybody okay with Rule 8? All right. Rule 9. Rule 9 says that the location of each contact associated with the coil can and should be specified. I'm adding the should. The rungs with the normally open contacts are associated with dashes. I don't always see dashes. A lot of times it's just written out there just like it is at the bottom down here. So we basically don't put anything with a normally open. If it's got anything behind it, an associated, an asterisk, a prime tilde, an underline, they're all considered to be normally closed. And I didn't put the star. I forgot about the asterisk. So we covered that just a minute ago too. All right, so that is Chapter 5. So do y'all have any questions on Chapter 5? There are a few more diagrams in here. It goes through how to draw relay logic. I think. No, it goes through how you run them, how they work. But we kind of did that on a simple one, so. Okay, questions for Chapter 5. One through 4 are test questions. So I would suggest you do 1 through 4 for sure. Those weren't in the old book, so. Write them down, 1 through 4. Okay, what? Let's see. Working. Here we go. All right, page 100. I swear. So I'm putting them at the end of my PowerPoint. Page 100, 1 through 4. Do what now? Correct. Chapter 4, 1, 2, and 6. Chapter 5, 1 through 4, and I'm going to say 7. I want you to do one. I want you to try one relay logic. If you cannot draw that, do not panic, but make an attempt at it. Chapter 4, 1, 2, and 6. Chapter 5, 1 through 4, and 7. 1, 2, 3, 4, 7. Is this chapter 5? Yeah. One, 2, and 6. All right, questions? We have one more chapter to cover, and we're going to do it. We'll probably do, well, I say one more chapter before we get to programming. So this is, the next one is our programming chapter. When I do this one, I tend to do this one from the lab because I can sit in here and tell you about programming, but it does absolutely no good. I've tried it doing it from in here, and it just didn't work. So what we will do on Monday? Today's Wednesday, isn't it? So what we will do on Monday, we are going to cover the programming part of Chapter 6. If you look at the first few things in Chapter 6, it starts back through those same rules. So the same rules apply for PLCs as it does for motor controls, relay logic, yep. But we're going to go through the programming steps, and what I'm going to try to do this time is I'm going to take the computer, have the computer over there so that we can walk through it and I can record it. So if you need to go back and listen to it again, you can go back and listen to it again. There are some steps that we have to go through, and sitting in here doing them, you won't remember them. And then I'll have to go through them again when we get in the lab anyway. So be prepared to go to lab. Make sure you have your lab book. The couple of differences, and I'll cover this again, but a couple of differences is motor in relay, that's a push button. In PLC logic, that's a push button. Do what? Everything's a contact. Okay? You have normally open and normally closed contacts. And that's why we have to say that they're push buttons, because we don't know. If you go out to the factory floor and you've got to find the problem and everything's labeled as a contact and I have no description whatsoever, how the heck are you going to find it? Okay? So you've got to think about other people, and like I told you the other day, please don't be one of those that don't want to share your knowledge. Because just remember, somebody shared theirs with you. Okay? All right. Yeah, and that's not really a good draw, and I kind of crooked here, so let me do it correctly here. It's supposed to be just 2 lines and 2 lines. It's hard to draw when that screen's moving, though. All right, so everything's contacts, and in relay logic, we have a relay that's a circle, and then we have the lights have little things coming off of them, and the motor's a circle with an M in it. And in PLC logic, that's an output. Everything's a circle, so we name it something. Okay? So if all outputs are circles and all inputs, the only description you get, the only other input you have is a normally closed, basically. Okay? So if all inputs are contactors, either normally open or normally closed, and all outputs are circles, how confusing could I make a diagram? Yeah. So let's don't do that. Okay? So make sure they're quite descriptive. So when I come to look at your circuit, please have them labeled, and I'll show you how to label them also. So any more? Mm-hmm. They better be labeled, but sometimes they don't. But that's the whole point of this. If you put in the diagram and you program it, do it like you would want it to be done if it was handed to you, and that's what I'm trying to get at. In the field, a lot of times you'll find a technician that didn't want you to know. So what does he do? He doesn't label anything because he knows what it is. He probably has his own drawing where he labeled everything. Okay? But you don't get that option. But most people that are programming PLCs will do that, because the guy that programs the PLC is not necessarily the guy that wired it up. Okay? So we usually have an electrician, a programming technician, and a maintenance person. And they all do have different jobs. So usually the PLC person will actually put this stuff in there. But I can't guarantee you that. Depends on where you go to work. Right here? This one? Okay, this one is a no-no. That was a bad draw. And this one? This one right here? Yeah, that's a normally closed. So this would be the same as this. And this would be the same as, let me draw it correctly. Although that's kind of crooked and kind of horribly drawn, that's what it would be. Sorry. And you can't hardly see it. It's gone off the screen, so. But it's got a line underneath it here. I'll do one up here. That's normally closed. All right, any more questions? I just drew another normally closed. Normally closed is under the bottom. Normally open is over the top. Normally open held closed would be And it made me mess up, so let me just. That would be normally open, held, closed. It's still over the top, it's just pushed down. Normally closed, held, open is like that. It's still under the bottom. It's still under the bottom, but it's being held open. You're right, it's not. And that's another thing in PLCs, we don't those can't really happen. I mean, we don't have them written that way. They're either normally open or they're normally closed. So that's the only two choices we really get. And it's a contact. So that's why I told you earlier that we would use the book for the symbols, because when we're doing symbols in here, we have very few. You know, one of the few that we have to know is the difference is a normally closed push button versus an overload contact. If it's normally closed and it's attached to line 1, it's a push button or a normally closed contact. If it's on line 2, then it's an overload. So it's an overload over here. Well, this is my right. So if it's over here, it's an overload. If it's on the left-hand side, then it's a contact. All right. So, any more questions?